everyone, so today we are going to discuss the exam questions for your previous exam. So we will start from the sections B, question number 16. So we look at question number 16 first. So for this one, most of you get correct for your calculation, but for definition you cannot score. So 16A, what is Doppler effect? So Doppler effect, what you have known that Doppler effect is actually the change in frequency of the source when the observer heard the frequencies of the source have a change. It's either by the source is moving or the observer is moving. So what is the keyword set when you want to write the definition? So it's actually apparent change in your frequency. So we have an apparent change in frequency here. And then we have the keyword, which is relative motions between the source and the observer. So we know that when there is a motion between the object or the source or the observer, then we will hurt the change of frequency of the source sounds. And then the second question to talk about is define frequency. So what is actually frequency? So frequency is the number of complete oscillations in 1 second. So whenever we talk about 10 Hertz, 10 Hertz means we have 10 complete circles in 1 second. Okay, 10 complete circles in 1 second. Okay. So the next question is about the calculation part. So we have two questions for the Doppler effect, which you have to calculate the apparent frequency when the source is moving. So we have frequency of a police car siren is 500 Hertz. So we have for question 1 first, we have a source and an observer where the initial frequency of the source is equal to 500 Hertz. Okay, remember that the directions of your sound is always pointed towards the observer. So this V is actually the speed of sound. So your speed of sound is given at here, which is equal to 330 meters per second. So V is always pointed to the observer. So you have to calculate the apparent frequency received by a stationary observer. So stationary observer means the observer is not moving when the car approaches. So approach means your source is moving towards the observer. So we have this direction as your US, which is your speed of your source. So when we have both V and US in the same direction, so they will be in negative value. While for opposite directions, so we will have a positive. So in other words, in order to calculate your apparent frequency, which is equal to, so remember it's US is at the bottom part, so V over V minus US. Why? Because they are in the same direction, so V minus US times the initial frequency. So we have 330 divided by 330 minus 30, which is moving with 30 meters per second, so times with 500. So you will get your answer as 550 Hertz. So 550 Hertz. So okay. So now we go for the second calculation part, which is when the car moves away. So still we have a source and observer. The speed of sound is always pointed towards the observer, and now the car is moved away. So your US is moving away from observer. So your US is in opposite directions with V. So opposite means positive value. So in other words, you want to calculate your apparent frequency will be V over V plus. US times F. So plus, because you have your V and US in the opposite directions. So you have substitute inside the values 330 divided by 330 plus 30, right? Like 30 meters per second times 500. So you will get your answer as 458. Right. So it can be either be your answer can live as two significant figures or three significant figures. So that's it for this question.